Hello friends and welcome back to lesson number 6. We are studying Indian agriculture and this is the fifth video of this lesson. In this video friends, we are going to study about cropping intensity. This is another concept when it comes to agriculture sector. And we have been studying about the major cropping patterns in our country. We have also seen what are the various factors that affect cropping patterns. We have also seen what is the historical evolution of cropping pattern in our country. Cropping intensity is a slightly different concept, which loosely means as to how many crops are grown per year on a given land. Okay, so that is a loose definition. We'll see exactly what it means. And ultimately it affects the cropping patterns, friends. If the cropping intensity is more, means more crops are grown on the same land in a given year, and therefore the cropping patterns emerge depending on that. We'll also study about sustainability. So we know that ultimately land is a resource, soil is a resource, and you cannot keep on exploiting it. If you grow a lot of crops, too much pressure on the soil, on water, ultimately it will affect the sustainability also in the long run. So we'll study this topic here. Now let us look at the definition of cropping intensity first. What is cropping intensity? Cropping intensity refers to how intensively the available agricultural land is used during a year, right? It indicates the number of crops grown on the same field in a agricultural year. So for example, in a agricultural year 2023-24, this is a financial year. If this is a patch of land, say it belongs to one farmer, it is 5 acres. So how many crops are grown on this land in a given year? That means cropping intensity. For the complete village or the complete district or the complete country, cropping intensity formula is given as follows. So cropping intensity in percentage is equal to gross cropped area divided by the net sown area multiplied by 100. Now what it means, I'll tell you. Now gross cropped area is the total area sown once plus the area sown more than once during a year. Now I'll explain it to you. For example, this is a village. Okay, in this village, say there are 10 farmers and these are the 10 plots of those farmers. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the 10 agricultural land. Now this farmer number 1, farmer number 3, 5, 6, 7 and 8. These are the farmers who grow. And all of these plots individually, they say they are 2 acres. So the total area of this village is 20 acres. This is just an example I'm giving it to you. Now out of these 10 farmers, this farmer number 1, 3, 5, 6, 7, 8, 6 farmers, they grow first rice in Kharif, and in winter, that is in Rabi, they will also grow wheat. Okay, so they take 2 crops in a given year. So this is grown twice and twice. So in a given year, for these 6 farmers, what is the net sown area? What is the net sown area? Net sown area is the agriculture land that is available. That is 2 acres multiplied by 6 farmers. That is 12 acres. That is a net sown area for these 6 farmers. Plus this remaining 4 farmers. That is farmer number 2, 4, 9 and 10. The net sown area will be 2 acres multiplied by 4. That is 8. Okay, so 20 acres is the net sown area in this particular village. These farmers, farmer number 2, 4, 9 and 10. Now out of this, farmer number 9 and 10, they will sow, they will take say 3 crops here. So they will also take rice, wheat, and then later on they will also grow fodder crops, say for example. So number 9 and 10, farmer number 9 and 10, they are growing 3 crops. So they are growing, they are using this same land 3 times in a year. So in that case, what will be the gross cropped area? It will be 2 acres. It will be 2 acres grown 3 times, and there are two such farmers. Okay, two such farmers. So for them the gross cropped area is 12 acres. Okay, for them, for these two, the gross cropped area is 12 acres. And farmer number 2 and 4, they are not they are not growing anything, say for example. So their land is fallow, they are not growing anything. So for this village, what is the total gross cropped area? Gross cropped area for farmer number 9 and 10 is 12 acres. For farmer number 1, 3, 5, 6, 7, 8, it is 2 acres. Multiply by 2 crops per year, multiply by how many farmers? 6. So this is total 24 acres, right? This is total 24 acres. Now another, these 2 and 4, they are not growing anything, so it is 0. So the total gross cropped area becomes here 36 acres. Whereas your net sown area is basically 20 acres that we have seen. So the cropping intensity will be 36 divided by 20 multiplied by 100. So this is the intensity of cropping on that particular in that particular village. Similarly, it is calculated for the entire district, for the entire state, for the entire country also, right? So net sown area is actual land sown with crops during the year. Now in this particular example, since number 2 and 4 they are not sowing anything, so it will not be considered in the net sown area. So net sown area will be 20 minus 4 acres for these two farmers. It will be only 16. So our formula becomes 36 divided by 16 here, because they are not growing anything. It doesn't come under the sown area. So this is the actual cropping intensity. If they had grown say one crop in a given year, so it would be 20, right? And the gross cropped area will also increase by 4. So in that case it will become 40 divided by 20. So 200%. Okay? So please try to understand this concept. Now what is the importance of cropping intensity? Measures land use efficiency, how efficiently we are using the land, how many times we are taking produce out of it. Higher cropping intensity means better utilization of limited land resources. It indicates potential productivity of agricultural system. So how much production can we obtain from the given agricultural land, that is indicated by the cropping intensity. Now cropping intensity in India, what are the trends? Okay, let us see the data. Now the net sown area of our country is approximately 141 million hectares. This is the net sown area of our country where at least one crop is taken. Gross cropped area in our country is 198 million hectare, and average cropping intensity becomes 198 divided by 141 multiplied by 100. So it is approximately again 141%. Okay, so this is the approximate cropping intensity of our country. Let us look at statewide some of the examples. In Punjab, cropping intensity is almost 185%. West Bengal, it is 180%. Rajasthan, it is 110%. Odisha, it is 125%. Now see, Punjab and West Bengal, they are able to have almost 200%, 180% cropping intensity. What could be the reason? Green revolution, good crops, irrigation, right? Good irrigation, then good variety of seeds. So these are the reasons why they are able to grow more than one crop. Rajasthan, water constraints. Odisha, it is slowly improving with irrigation, but irrigation systems have been poor historically. So try to understand that this ultimately affects the socio-economic condition of the farmers also. So the more crops farmers are growing, the more income they are earning and the better socio-economic conditions they are having. Now what are the various factors affecting the cropping intensity? Irrigation facilities, of course. So higher irrigation means more assured cropping. So people are growing more crops. Example in Punjab and Haryana. Then climate, long areas having long growing seasons allow 2 to 3 crops per year. Example in Kerala and Tamil Nadu. Soil fertility, right? How fertile the soil is. Rich alluvial soil supports multiple cropping. In example in North India. Technological access. Technology access is also important, like high yield variety seeds, mechanization, post-harvest management. All these factors also affect how easily a farmer can grow more than one crop in a given land. Then market and MSP incentives. Assured procurement encourages double cropping, like for example rice and wheat cycle in Punjab and Haryana and also some parts of UP. Labor productivity and mechanization are also important in labor scarce regions where the labor availability is very low. Second or third crops becomes difficult. It becomes skipped, right? They skip it. Now, what is sustainable cropping intensity? What are the needs and challenges in order to make the agriculture sector sustainable? While high cropping intensity seems desirable because we want to increase the incomes of the farmers, unsustainable intensification can harm long-term agricultural health. Okay, because it will deteriorate soil health, groundwater, so many other things. Sustainability challenges are there. Soil degradation. Continuous cropping leads to nutrient depletion in the soil, especially micronutrients like zinc and boron. Example, Punjab's rice wheat belt shows declining organic carbon and soil health. So this is a emerging problem right now. Groundwater overuse, high cropping intensity demands frequent irrigation. And example of this is that water table in northwestern India, that is Punjab, Haryana, Rajasthan, has dropped significantly due to water intensive paddy production. Pest and disease cycles also happens. Continuous cropping encourages buildup of pathogens and pests due to lack of crop rotation. So if there is no crop rotation also, so there is it is very likely that pathogens and pest attack will increase because they grow more if the continuous crop is present on the field. Input overuse, fertilizers and pesticide intensity increases with multiple crops. It leads to chemical runoff, nitrate pollution and resistance issues also. Labor and resource pressure, high labor requirement leads to increased cost and migrant dependency. If you are growing more than one crop, then you may require more labor and therefore migrant dependency will increase. Labor cost will also increase. What are the various sustainable solutions to these problems? To maintain high cropping intensity without ecological damage, this is important, without ecological damage, integrated approach are necessary. What are these integrated approach? One is crop rotation. So you do crop rotation. This year you are growing rice, next year grow bajra or cotton, something like that. Alternating deep rooted and shallow rooted crops, cereals with legumes. So this results into positive allelopathy. Okay. Now what is allelopathy? I'll explain to you at the end of this video. Rice, lentil, vegetable in Bihar to restore nitrogen, improve soil structure. Right. So this is an example that is actually happening in Bihar. Then integrated nitrogen management, combining organic manures, biofertilizers with chemical inputs, reduces dependency on synthetic inputs. Okay. So we have to do nitrogen management of the soil by having organic manures, biofertilizers with chemical inputs. So use chemical fertilizers, but at the same time also use organic fertilizers and biofertilizers also, so that there is a proper nitrogen management. It reduces dependence on synthetic inputs, that is chemical inputs. Conservation agriculture, minimal tillage, do agriculture in such a way that there is minimum tillage, permanent soil cover, example residue retention, and crop diversification. So residue retention meaning, if for example rice you are growing, you are leaving the residue on the field itself and then you are growing some other crop. So that is residue retention. Again, it leads to positive allelopathy. Reduces erosion and improves carbon sequestration. Basically carbon storage in the soil is called carbon sequestration. So this conservation agriculture results into reduced soil erosion and also improves carbon storage in the soil, which is ultimately an organic matter, right? Helps with agricultural productivity. Then the next one is efficient irrigation system. Use small irrigation systems, micro irrigation, drip and sprinkler systems, which reduce water usage and prevent salinization. So if you are having water on the land for a long period of time, it results into salinization of soil. So there are some salts which get accumulated on the soil surface. So that will be reduced if you use drip and sprinkler irrigation instead of flood irrigation. We'll study about these irrigation systems when we study the irrigation systems in our country. So you must have heard about drip and sprinkler irrigation, right? Use of solar powered micro irrigation in Maharashtra shows promising results. So already Maharashtra is showing some positive results. Then multiple cropping systems with agroforestry. Example, poplar wheat system improves resource use efficiency. So basically do forestry, meaning plant trees in your agriculture so that it improves your soil it checks your soil erosion. So poplar is a tree plus weed system improves resource use efficiency. So agroforestry is a promising way to do that. Then inclusion of millets and pulses also, like ragi, bajra, chickpea. So they have a low, they are low input and high output systems. They also improve the system resilience and they are low input, right? Now, what are the various examples of sustainable high intensity systems? So, from various states, one is rice, wheat, moong. It is practiced in Haryana and Punjab and Bihar. And what are the benefits? It adds nitrogen and breaks the pest cycles, on the field. Then another one is maize, potato, wheat, practiced in UP and Bihar. Efficient use of long winters, right? Then the next one is rice, lentils, vegetables, practiced in West Bengal and Odisha. Enhances soil fertility and also increases income of the farmers. Then cotton, chickpea, practiced in Maharashtra and also Telangana. What it does, it balances water usage, uses post monsoon soil moisture. Then the next one is agroforestry with poplar. This we have seen above. Punjab and UP practices tree roots improve water retention and income diversification also. At the same time checks the soil erosion also. Now India must use the smart intensification actually. So we know that smart intensification means increase the cropping intensity, but without degrading the environment, without degrading the soil, without degrading without degrading the ecology, without degrading the water table. So that is important, right? Now how it can be done? By using the traditional wisdom, using organic manure, various traditional means of doing things. Then modern science also needs to be used, but efficiently and wisely. Policy support from the government in order to promote things like organic manure, millets, and other crop rotation. Farmer education is also equally important, so that farmers know that by using excessive fertilizers, excessive chemical inputs, we are actually degrading the quality of soil and reducing the long term sustainability. So this is about the cropping intensity and sustainability in Indian agriculture. Now let me very briefly tell you about the allelopathy concept. So allelopathy is basically a phenomenon where one plant releases biochemicals. So or they are also called allelochemicals into the environment, that is into the soil or air, right, or into the water, that either inhibit or influence or support the growth, survival or reproduction of other plants. Okay, basically it provides synergy. Okay, basically it provides synergy. So synergy is obtained here. Now allelopathy can be positive or negative. Okay, it can be positive or negative. Negative meaning they release such chemicals that it inhibits or inhibits the growth and survival of other plants. It can be positive meaning it supports the growth and reproduction of other crops. For example, I'll tell you the example of rice. Okay, so rice will release such a chemical which are phenolic acids, which will inhibit the growth of weeds. So weeds are the small plants which will which will inhibit the growth of another crops. So in that way it is a positive thing for the farmer. So rice release such acids, such chemicals that will inhibit the growth of weeds. Okay, then there are many such other examples also. So basically just try to understand that allelopathy is a concept, is a phenomenon where one plant will release some chemicals in the soil or air or water that will affect the production of or the growth of other crops that will happen. So it can result into synergistic system whereby one plant is supporting another or the crop rotation becomes easier in that case. Okay, so this is allelopathy, and we have seen here that positive allelopathy is seen in some of the examples like residue retention results into conservation agriculture. Then some deep rooted and shallow rooted crops, cereals with legumes, results into better growth of both the crops. So this is positive allelopathy. In the next video we'll continue with Indian agriculture. Thank you.